T.A.Q.T on Twitter and GitHub. Find me on there. And just a contractor. Been doing that for quite a while now. Just working different contracts. I do a lot of Ruby more than anything. I'm really trying to get more into Erlang and Elixir stuff though, because I really feel that that's where everything's going to move towards. So that's me. And this is what I'm talking about. It's the HAQT pattern. And it stands for a Handler Action Query Transform. And I've got the GitHub repo. I've got the slides up there and markdown files, some notes and stuff. As soon as this is over, like I've been updating this all day. I'll push the latest slides when this is done. So you guys can check it out, and you can pull down the little demo app and run it and check it out and stuff. So this pattern is just an idea that we've been using with one of my clients for the last 2 years with a team. We've had this distributed project, and we were like basically took like a message bus and had a bunch of small autonomous services. I don't want to call them microservices because that's such an overloaded term now. But and this pattern really helped us because we had an API and we had like 10 other services on the bus that we had to create, and we had to do it all in Node.js. And so by using this pattern, it really helped us to be flexible and have like consistent stuff without like grabbing some framework somewhere. And that was really nice. It also was really nice because things kept changing. We started out using, I think we started with RabbitMQ, and we were using that kind of as our message bus, and that didn't work too well. Then we switched over to Kafka. We had Kafka running for a while. And then we decided, you know, we could write our own message bus because there was other problems with the DevOps team and keeping the server up all the time. Like, it shouldn't be a problem, but it was. We wrote our own version of a simple message bus is what we called it, and then they came back and they're like, okay, that's great, you got to play with that for a month, go back to using Kafka, and then we've done that for 3 months, and now they're like, no, let's use Rabbit again. So like, we're, with this client, we're in this very like up and down kind of relationship with what tools we get to use. It kind of depends on what the flavor of the month is. And this patterns work great for that, because when a tool changes, usually there's just one part that we have to change to make it work with that tool, and we're not touching business logic, which I think that's the best part about this idea of pattern. The main point that I want to stress with this is just an idea. This is not a framework. It's not a new set of tools. There's no generators. I'm not going to create a library for it. We're not going to do any of that stuff. It's just an idea that we want to get out there. And if it works for you, that's great. Awesome. Use it. If not, there's probably something else better that works for you in whatever situation you're in. And we're just trying to take it to different contexts, different languages, and then just see where does it work well. As I've been playing around with this, I've found a nice niche, especially with the updates for Phoenix, where things are kind of getting moved around a little bit, where this might fit in very nicely with Phoenix apps. So this idea, let me say, where'd this idea come from? This is Ethan, Juan Paco on GitHub. I have no idea why. He still hasn't told me the story. But Ethan Garofalo on Twitter, from Provo, he has his own consultancy as well. We've been contracting the same client for the last 2 years. Great guy. Learn all the nodes. That was his site. If anybody had ever had to learn Node.js, he's also got all his videos on YouTube, like years worth of, hey, this is how you learn how to do Node.js right. Brilliant engineer, but this was part of his idea. He used it in one of our first applications that we developed, and then from there we took it out and made a pattern of it and used it on all the rest of them, and kind of helped refine it as we used it. We would give feedback and see, okay, how could this be better? What else could we do with it? Where did it work? Where did it not work? And over the course of 2 years, I think we've got it worked out pretty good. We called it the HAQT pattern because it was easy to remember, because myself, whenever I was developing, I'd always forget, which files did I need? And so it was easy to say, HAQT, Handler Action Query Transform. And so I make sure, okay, I've got all 3 of those for this module. That's all we need. You're good. This idea builds upon many other ideas in software development, just like any great idea, right? It's never just like this big explosion spark. Like, we're always building on top of what other great people have done to get something even greater, right? So let's take a look at some of the ideas that this was founded on. So this guy, does anybody know this guy? Eric Meyer? He's funny. He did a MOOC for edX on functional programming. He did it all in Haskell though, but it was super fun class. Learned a lot from it. He does a lot of great talks. And this is from a talk that he gave about hacker way alternative to Agile. He kind of goes off the rails on some really crazy stuff in that talk about getting like Agile developers or like clowns, but there was some good stuff in there. And this is one of the good things that he said was that the only architecture that he knows that really works is a layered architecture, right? Just like the OSI, right? It's layers and it works because n layer can only talk to n plus 1, right? N plus 2, like you have to go through the layers to get all the way down. That's why it works. And then I kind of got this question. I was like, if you've ever seen this guy on YouTube, he always wears tie-dye. Everything I've seen. So I had to ask Google, does Eric Meyer own a shirt that is not tie-dye? And Google said, yes. He owns exactly one shirt that is not tie-dye. Everything else is tie-dye. And it's a cobalt shirt. But then I remember we're trying to solve problems here and not worried about his wardrobe. So let's get back to discussing the layered idea. And when thinking about the layer, I was like, well, what about other architectural ideas that are out there? And we got this one. This was Elixir Days. This is Paul Lamb's talk. And that was the best slide at the whole entire talk. and when I saw it, I was like, oh my god, that is so funny. But like, why? Why does this, like, because this rings true, right? We all know this, right? This rings true because we've seen those apps that were big monoliths, and then somebody somewhere said, oh, well, like, let's separate it. We're going to call it service-oriented architecture, or let's really separate it and splatter it, and we're going to call it, you know, it's like if you're just moving the stuff around, that's not really what service-oriented architecture or microservices are really about. Separating the code does not always separate concerns. But the best slide ever. So getting back to the layers, right? That's what it's all about. We like the layers. And of course we all know that with like something like this, like a, I don't know, 5-7 layer bean dip thing. The thing is that you can't access the bean layer, right? Directly. That's the thing. Like if you don't remember anything else, just remember I'm funny and there's layers, right? You can't access the bean layer directly. You have to go through the sour cream, you have to go through the guacamole, you have to go through the salsa, and then you get the beans, right? That's what it's all about. And it's by design, because nobody wants a tortilla chip with just beans on it, right? Okay, so another one of the great ideas that was behind this is Uncle Bob's talk. Ruby Midwest, keynote, lost years, architecture. I think this was in Amos's last talk too. He had this one. But there's the one part in there where he's like showing the top level directory, and he's like, what is this? And all you can say is, I don't know, it's a Rails app. And they're like, well, what's it do? Well, I don't know, Railsy stuff. Probably stick shit in a database somewhere, I don't know, right? That's what Rails apps do. Right? So why should the top level directory structure of your application communicate the framework you're using? It really shouldn't, right? When you look in the lib directory of an Elixir app, should you just see, oh, hey, it's a Phoenix app? You should really see, like, what is this application do? It should communicate the intent of your application, not your framework. So this was a big part of this too. It's totally cool. And then there's this guy. Does anybody know this guy? I love the hat thing he's got going on there. I'm not even sure what that is, but he gave a talk, it was the Boundaries talk, and he goes over like a lot of things. Like it's a pretty long talk, and he covers like different things why they don't work. But there's a couple of things that he hits on, and this is like if you were to describe a function for addition, right, for plus, right, what would it be? It would take 2 inputs, or if you're querying, it would take an input, return a function that takes an input, and then, depending on what language you're in, and then it returns a value. There's no dependencies, there's no side effects, there's no, it's a pure function, right? So you have natural isolation in that. Testing that is simple, right? You could write generated tests for that. That would be amazing because it's so simple. And that's where a lot of people run into problems is they're not thinking like, not only should your functions be like that, but your modules should be like that, right? Anywhere that you can. And so this was really cool. And he hit on it at the end and basically described Erlang. He even says it in the talk. He's like, yeah, and basically this is what Erlang does. But he described the inner parts as being the functional core, these pure functional parts that are your domain logic in the center, and then these outer parts being the imperative shell that surrounds them. So anything that has side effects, dependencies, something that writes out to a database, something that takes input from something else, surrounds that functional core part. And then he said, well, like if you just had like a big monolith with a functional core and an imperative shell, it wouldn't really work, right? He's like, you got to have little things. And it's like, oh yeah, processes, yeah, you know what that is. But I always thought his slide was like the way he talked about it kind of reminded me of like jelly-filled donuts, but because you had the functional gooiness on the inside. I kind of like sandwiches though. That's where the HAQT pattern is. It's more of a sandwich instead of a gooey donut. And then there's also this Jessica. I'm sure everybody knows Jessica. Does anybody not know Jessica? Right? You should follow her. Her tweets are amazing. Her talks are great too. She used to talk a lot at the Ruby group, and now she talks like everywhere. It's quite impressive. She did this tweet a couple years back. How to make a command line application, write the library that does the work, and then write a command line client that talks to it, right? That's just your interface. That's another big idea in this is that the hacked part of this is your domain logic. And then whatever your interface is, I don't care. Like API, GraphQL, Web, CLI, RabbitQ, Kinesis in AWS, pumping messages into it, doesn't really matter, right? So that's how we should be building this stuff, right? Your domain logic should be separate somehow. There should be some separation. And that's where this comes in, right? So the HAQT pattern, handler, action, query, transform. It's a way to structure your domain logic into separate modules that are made up of layers that data is piped through. And this is independent of your application's interfaces on the input side and the output side, right? I really liked it with Elixir because like we already have pipelines. This is like totally a thing, right? Like it fits in Elixir because that's what you're doing. You're just like piping stuff through. It's like the same thing. I'll cover each module real quick. The handler would take input, like whatever it's coming from, if it's a web API call or whatever. Your handler just takes that input and knows what your actions need. It only knows about n+1, right? It knows about your actions. That's all it does. It takes the input, knows what your actions need. When it gets a response from the actions, it knows how to respond to whatever that interface is, right? Whether it was a web interface or maybe you're doing something with messages, you have a bus, or it knows about that and how to respond back when it gets a response. That's it. It keeps it nice and simple.
Todd?
Yep.
So that's sort of like a controller in Rails if you have a service object, so all it does is get the pieces and hand it off.
Kinda, yeah. Except for without Rails.
Well, yeah.
But
try to put it in context I understand.
no, yeah. So the actions gets the data from the handler. That's where you want to do your validation, your error handling. If something's not right, data's wrong, throw it back or whatever you need to do with it. And then if your data's good, once it's past validation, you can call the right queries, right? And this is all this does. This is just your middleman, go-between, right? And the queries, basically, it just gets data, it transforms it if it needs to. Like sometimes you'll have a transformation. I don't always use transformations. I found sometimes we need it, sometimes we don't. It's one of those things, it's like mayo, like sometimes you want it, sometimes you don't on a sandwich. Some people don't like it, some people do. It's you know, but so you perform any transformations, like you switch it up to something or say you're going to do a certain type of object, and then you execute the actual query. So your queries file is wrapping whatever your persistence is, whatever that outside is, which could be anything, right? This could be another API, it could be GraphQL, it could be another message bus, you're just popping messages through, it could be Postgres, it could be whatever, it doesn't matter, right? But this is a layer that wraps that, and this is how it separates the main object, so that what's in the middle doesn't really have to change, right? And then transforms, those are so simple. Transform the data. Usually transform functions, we write them as like this to that, and then you write another one that's that to this if you need to do a transformation. So throwing data into something, you do it this to that, and pulling data out, you do it that to this, whatever those objects are, you know, whatever they represent. And when you put it all together, you get a sandwich. It looks like this, kind of this way sandwich. So you get your data in from your HTTP, event string, command line tool, message queue, message from another process, because you can totally do that with Elixir and stuff. Data comes in, goes to the handler, action, query, and then comes out the other side to a database, ETS, gen server, flat file, API call. Doesn't matter, right? All we're concerned with just the flow of stuff through the middle. And what that gives us is natural isolation. Right? We get a beach, we get some palm trees and a pool and a nice view. That's what you get when you write code like that. So your modules are now like little islands with the domain logic hanging out under the palm trees, sipping pina coladas while waiting for the next event to come into the dock. There's only one thing, right? Another great part about this is separation like this leads to thought. You have to think about what you're doing, and you have to really think about your domain logic. And now, if you look at code, yay! Okay, so this is the application. And in our lib, we have registration. So what's that tell us right off the bat? This is an application about registering something, right? At least we know that, right? It's for registering stuff. I thought this would be a good thing since I just got back from the conference, like if you were to write a conference registration application that would register users. And it's super duper simple. We've got, I messed around with some OTP stuff because I haven't got to do a lot of that yet. So like there's tons of like, I probably have way too many supervisors going on, but I just totally wanted to like do what I could with it. And it was super fun. So in here we've got our web part. We'll look at that really quick. That one. Right, and so I'm just doing plug router and a cowboy adapter. So not like full on Phoenix, but just enough to get like an API running, right? And we've got some default responses that we can send back, and we've got one endpoint, just a post endpoint registration event. It takes an event, kind of like I was trying to do like a GraphQL thing without actually doing GraphQL. Post to it, and send it some JSON, and it knows what to do with it off of what the event type is. It does a little bit of conversion stuff in here, and then sends it off to the handler. It says, handler, handle this event type, right? Then we have our handler. And so handler is a gen server. I don't remember why I made it. Oh, I made it a gen server because I wanted it to be running in its own like process tree kind of thing, in its own like branch of it, I guess you'd call it. I'm still new to like the OTP terms, but I wanted to run it in its own thing, so if like that crashes out, like it just gets restarted, right? So it has its own supervisor that'll restart it if something breaks, which is something breaks with this probably because the data was like really way off and probably should have hit to the back end anyways. So we've got our handle event type, which is the gen server call. We've got a bunch of different event types that we can handle, and we're matching on those. And then our handle calls and handle casts. I did handle call for anything that was going to return data from the back end, so it would sit there and wait, and then everything else I really wanted to do a cast, because I just wanted to do a, hey, I heard you kind of reply from the API, and keep it going. Like, it's very, I wanted to try to be as event-driven as possible, right? So just like, hey, I got you, we'll do something about it, it might work, it might not, I don't know. So that's why I use cast there. And then we've just got calls, the actions. There's not a whole lot going on here other than pretty much just wrapping the calls. In other applications I've done with this, sometimes there's more about, like if you're getting data from a form that came in through a React app or something like that, and that comes in through the JSON, usually you got to pick out all the little parts that you really care about. But with these, we're pretty much sending it straight across. So there's not a ton to do in here. In the actions, we have our count functions up here, and those are pretty easy. And then our registration and unregister, and then we have some validations. And I don't know, I was kind of weird with the validations, and I kind of went back and forth between validating here and validating in the queries before it gets to the database, and ended up like this still feels like the best spot here is to have it in the actions for doing the validation stuff. That way, just like the queries never sees it, and it's not going to worry about it. Anything that makes it to the query has already been validated, and you're pretty sure it's good. Right?
Todd, what about like the problem of duplicate username? Because that's going to have to get the query. You just have an error in a different place.
Yeah, wait, let me think. I'm sure I'm handling that. I might not be. This is still pretty simple. Let's take a look at validation.
That's the sort of validation that's not like the others. In fact, maybe calling it validation is probably a mistake.
Yeah. No, I'm just validating. I get the proper types as far as like my keys in that, I don't want to say object, but map, right? That's the only thing I'm really validating on here. This is going to get more complex, and I will be looking at addressing that because I want to keep working on this. And I want to get like right now, this is like what I threw together in like a week, and I want to have like other modules and actually do a lot more with this. But right now it is super simple, and yeah, I don't think I'm handling that. And the way that it stores it. Well, I'll save that for when we get to the store part. But yeah, no, totally. I think it's not going to go down. Well, yeah. So there's validations, back to the actions, and so we're just doing validating, and we're doing this cast thing or this weird thing with casting an integer. And this is probably really cruddy. This could be way better, but it works for right now. Until I figure out why that was weird. And in the queries, so we have a registrations, which this is like really silly simple, right? Like I'm not actually making calls out to something to get a count from something. I'm just counting the things, right? Just to keep it as simple as possible right now. They call the registrations, I get all the registrations, I filter on type for the counts, or I call a register or unregister for register and unregister, right? So what I want to move to with this is like an event sourcing system, and I haven't got that quite figured out yet. So it's just like this for now, but with an event sourcing system, we'd be like logging everything and then rolling up counts and storing them somewhere, but I haven't done that. This is also like pretty super simple. Yeah, a lot of this is. So we're not handling a whole lot of stuff, but just calling into the store for stuff. And then the store is just a gen server that we're storing state in. So no database, no Postgres, no nothing like that. After Amos's talk, I was like, okay, dude, I gotta see if I can build some sort of app without a database, no schema, no nothing, and see how it works. And actually, it works pretty good. We've got a store and a failover. The failover, if it dies though, and it's at the top of the tree, but if the failover dies, your app's dead anyways. But then you lose all data, right? So I need to like write out to like an ETS or something like that. I haven't done that yet, but that would be like the next thing is have like the failovers write out kind of thing. But other than that, it works really good. Like I can kill this and it'll spin back up and it'll pull from the failover every time it admits a new one. And so you can kill this thing like all day long. It's kind of fun. And so that's like all we're really doing is just getting state and storing state into this. And that's it. It's super duper simple. The failover is just you can load it and you can dump state into it, load it back out of it. That's it. It's just going to hold state for a little bit. And that's all it is. Super duper simple. The thing that I like also with this is that so we have registrations here. There could obviously be something else, like maybe they want something where they post the videos afterwards or whatever kind of user story you can think of. You can actually have a store that isn't, it's not like the store. It's not like in Rails you have like one database.
It's a main validation, right?
Have like a validations layer in there.
Yeah, but half doesn't sound as good as half.
Yeah, sure.
That's the whole point right there.
HAQT.
It's really hard to pronounce. Well, like you said, though, this is, use the pieces that are useful.
Exactly.
Have the pieces that are useful.
Right. We shouldn't cargo cult the whole thing. Use what works for you, and and then if you have other ideas, that's great. I'll totally put that in there, and we'll play around with it and see. Because and that's it. That's when I think about this. I think about. Let me find a good example. Probably of course not. Well, I have pipes somewhere because I love them and I use them everywhere. So I think this is what I think about. When I think about the pattern, I think about how we use pipes in Elixir to pipe data through, right? And adding a layer or removing a layer is the same idea, right? We don't need a validation